Hello viewers, we are pleased to bring to you another program in the Teleschool Senior Series. The subject today is trigonometry. The aim of this program is to cover approximately half of the topic on trigonometry in your syllabus. In fact, we will talk about the 6 trigonometric functions, the sine chart, the relation chart, the main trigonometric identities, the double angle formulae, and their use in solving trigonometric equations. So, let's start. Consider a right angle triangle. We have labeled the sides as H for the hypotenuse, A for the adjacent side, O the opposite. That is, H represents the length of the hypotenuse, A the length of the adjacent side, and O the length of the opposite side. And the acute angle is represented by theta. And we'll define the 6 trigonometric functions for this angle theta. Now, sine theta is equal to the length of the opposite side divided by the length of the hypotenuse. Cosine theta, or simply cos theta, is equal to the length of the adjacent side divided by the length of the hypotenuse. Tangent theta, or simply tan theta, is equal to sine theta divided by cos theta, or it is also equal to length of opposite divided by length of adjacent side. Cosecant theta, or simply cosec theta, is equal to 1 over sine theta, and it is equal to length of hypotenuse divided by length of opposite. Secant theta, or simply sec theta, is equal to 1 over cos theta, and it is equal to hypotenuse over adjacent, length of adjacent side. Cotangent theta, or simply cot theta, is equal to 1 over tan theta. It is equal to cos theta over sine theta. It is also equal to length of adjacent side divided by length of opposite side. Also, remember that the value of cos and sine must always be between -1 and 1. You cannot have cos of an angle, for example, greater than 1, or, for example, equal to 2. However, tan theta and cot theta can take any value. Sec theta and cosec theta also can take any value except in the range -1 to 1. Now we are going to look at the sine chart. If I give you an angle, you must be able to tell me what is the sine. Of course, you will not be able to tell me what is the magnitude, because we are going to get the magnitude from the calculator. But you must be able to tell me what is the sine, whether it is positive or negative. For example, if I give you 125 degrees, you must be able to tell me whether cos of 125 degrees will be positive or negative. So, let's see the sine chart. We have divided the plane into 4 quadrants. The 4 quadrants, the first one, second one, third one, and fourth one. As you know that angles measured from the horizontal in a anti-clockwise direction are taken to be positive. Angles measured in a clockwise direction from horizontal are taken to be negative. And we have labeled the axis as 0 degrees or 0 radian, pi by 2 radian or 90 degrees, 180 degrees or pi radian, 270 degrees or 3 pi by 2 radian. Now, all the angles between 0 and 90, that is, all the angles in the first quadrant, will have their sine value, cos value, tan, cosec, sec, cot positive. Therefore, if I take an angle in the first quadrant, say 30 degrees, sine, cos, tan, cosec, sec, cot of 30 degrees will all be positive. But in the second quadrant, only sine and cosec of angles are positive. The remaining will be negative. Let's take an example. an angle in second quadrant, let's take, say, 150 degrees. Sine of 150 degrees and cosec of 150 degrees will be positive, but cos, sec, cot, and tan will be negative. You can take an example in radian, for example. In the second quadrant, let's take 2 radian. Sine of 2 radian will be positive. Consequently, cosec of 2 radian will be positive, but cos, sec, cot, and tan of 2 radian will be negative. Let's look at the third quadrant. In the third quadrant, tan and cot of angles will be positive. That is, all the angles in the third quadrant between 180 degrees to 270 degrees, or between pi radian to 3 pi by 2 radian, will have the tan value and the cot value positive, and the remaining will be negative. Let's take an example. In the third quadrant, 200 degrees. Tan and cot of 200 degrees will be positive, but sine, cos, cosec, and sec of 200 degrees will be negative. Or an example in radian, let's take 4 radian. Tan and cot of 4 radian will be positive, but sine, cos, cosec, and sec will be negative. Similarly, in the fourth quadrant, cos, sec of angles will be positive, but sine, tan, cosec, and cot will be negative. Let's take an example in the fourth quadrant. 300 degrees. Cos of 300 and sec of 300 will be positive, but sine, tan, cosec, and cot of 300 degrees will be negative. Oh, in terms of radian, if you take 6 radian, cos and sec of 6 radian will be positive, but sine, tan, cosec, and cot of 6 radian will be negative, because 6 radian is in the fourth quadrant. Now, we'll help you to remember this sign chart. There are quite a few mnemonics that have been devised to help you to remember the sign of the angles. In fact, the best way to remember is to remember which are the functions which are positive. Consequently, the remaining will be negative. So let's see. A. All of them are positive in first quadrant. Sine only is positive in second quadrant. Tan is positive in third quadrant. And cos is positive in the fourth quadrant. So you can think of it as follows. Add sugar to coffee. Or after school to cinema. Of course, don't go to cinema after school. I hope that these two mnemonics will help you to remember the sign of the trigonometric function. Now, as you have relatives, angles as well have relatives. An angle theta degrees in the first quadrant has an angle of 180 minus theta related to it in the second quadrant. In the third quadrant, the angle related to theta is 180 plus theta. And in the fourth quadrant, the angle related to the angle in the first quadrant is 360 minus theta. Oh, if you're working in radian, if you have an angle of alpha radian in first quadrant, then it is related to pi minus alpha in the second quadrant. It is related to pi plus alpha in the third quadrant, and 2 pi minus alpha in the fourth quadrant. Now, related angles have exactly the same value in magnitude for a trigonometric function. The magnitude will be the same, but the sign will differ. We are going to illustrate that by an example. Let's consider 30 degrees. So, the angles related to 30 degrees in the second quadrant is 150. That is 180 minus 30. In the third quadrant, it is 210. That is 180 plus 30. In the fourth quadrant, 360 minus 30. We have obtained the value of sine 30, cos 30, tan 30 from tables. That is, sin 30 is half, cos 30 is root 3 by 2, tan 30 is 1 over root 3. Now, let's find sin 150. First of all, can you tell me what will be the sign? Will it be positive or negative? Of course, 150 being in the second quadrant, the sign of 150 will be positive. Therefore, we'll say plus. But its magnitude will be exactly the same as that of sin 30, so half. So sin 150 is plus half. Can you tell me what will be cos 150? Cos 150 will be negative, first of all. Why? Because cos of all the angles in second quadrant are negative. So cos of 150 will be negative, but it will have the same magnitude as cos of 30. So it will be minus root 3 by 2. Similarly, tan 150 will be negative because 150 is in second quadrant. But its magnitude will be same as tan 30, that is 1 over root 3. Sin 210 degrees is equal to minus half. That is, sine of an angle in third quadrant is negative, but the magnitude is same as that of sin 30. Cos 210 will be equal to cos 30 in magnitude, but 210 being in third quadrant will be negative. Tan 210 will be equal to tan 30, that is 1 over root 3. Tan of angles in third quadrant being positive, therefore tan 210 will be plus 1 over root 3. Similarly, the angle related to 30 degrees in the fourth quadrant is 330 degrees. So sine of 330 degrees will be negative simply because 330 degrees in the fourth quadrant. So it will be negative, but its magnitude will be equal to sine 30, so half. So we'll write sine 330 is minus half. Cos 330 will be equal to cos 30, and the sign as well will be the same, simply because 330 is in fourth quadrant and cos of all angles in fourth quadrant are positive. Tan 330 degrees will be negative because tan is negative in fourth quadrant, but its magnitude will be the same, that is 1 over root 3. Now, you must have noted that we have written the values in exact form, that is using surds. And you know that calculators do not give answers in surd form. But according to your syllabus, you've got to remember the values of a few trigonometric functions in their exact form. And we have summarized all these values for you in a table. So let's see. 30 degrees, 45 degrees, and 60 degrees. You've got to remember the sine, cos, and tan value of the related angles in exact form. Now, 30 degrees in first quadrant will be related to 150 in second, 210 in third, and 330 in fourth. Now, they will all have the same magnitude. The sine value of 30, 150, 210, and 330 will be the same, that is equal to half. But sine is positive in first and second. It will be negative in third and fourth. Similarly, cos of 30, 150, 210, and 330 will have exactly the same magnitude, root 3 divided by 2. But cos is positive in first and fourth. Therefore, cos of 30 will be plus root 3 by 2. Cos of 330 will be plus root 3 by 2. But cos of 150 and 210 will be minus root 3 by 2. Similarly, tan of 30 degrees will be 1 over root 3. And the remaining as well will have the same value in magnitude. But tan is negative in second and fourth. So tan of 150 will be minus 1 over root 3. tan of 330 will be minus 1 over root 3. Similarly, you've got to remember that sine of 45 degrees and all the angles related to it will have the magnitude 1 over root 2. The cos of 45 degrees and all its related angles will have magnitude 1 over root 2 as well. And consequently, the tan of 45 degrees and all its related angles will have magnitude of 1. Of course, the sign will change. For example, tan is positive in first and third only, and in the remaining two it will be negative. Similarly, you've got to remember the exact form of the values of the trigonometric function for 60 degrees and the related angle, which are 120, 240 and 300. The sine value of 60 degrees and the related angles has a magnitude of square root of 3 by 2. So, and cos of 60 degrees and the related angles will have a magnitude of half. Tan of 60 degrees and the related angles will have a magnitude of root 3, but the sign will change. So you will have to memorize this exact form. Let's now show to you how to solve a simple trigonometric equation. The question is, solve sine x equal to half. That is, we want all the angles between 0 and 360 degrees that satisfy the equation sine x equal to half. So the first step is to apply the inverse sine function. That is, x equal to sine inverse half. The next step, we use the calculator to evaluate sine inverse half, and we get 30 degrees. 30 degrees is called the principal value of sine inverse half. The next step is to write down all the angles that will be related to 30 degrees. In second quadrant, it will be 180 minus 30, which is 150. In the third quadrant, it is 180 plus 30, which is 210. In the fourth quadrant, 360 minus 30, which is 330. Now, we are looking for sine x equal, we're looking for all those values of x which have their sine value equal to half. That is, sine x is positive. So we will take as solution only solution in those quadrants in which sine is positive. So we'll take solution in the first quadrant and the second quadrant. We'll discard the angle in the third and the fourth, because sine is negative here and we are looking for positive. Sine x is positive half, or we are looking for sine inverse plus half. So we'll say sine inverse plus half is 30 and 150. Hence x equal to 30 and 150. We'll take another example. We are going to look at the equation 4 cos x minus 30 is equal to 0.5. And we are looking for all the values of x which lie between 0 and 360 degrees and which satisfy this equation. The first step would be to divide by 4, so that we obtain cos x minus 30 is equal to 0.5 divided by 4, which gives us 0.125. Before we continue, note that cos x minus 30 is not equal to cos x minus cos 30. The next step would be to take the inverse. That is, cos x minus 30 is equal to 0.125 implies x minus 30 will be cos inverse 0.125. And we'll find this using the calculator, which is 82.8 degrees. The next step would be, as we did for the previous example, to find all the related angles. we have found 82.8 degrees from calculator, and this one we calculate it by taking 180 minus this value. The value in the third quadrant is obtained by adding 180 to 82.8. In the fourth quadrant, 360 minus 82.8. Now, we are looking for cos inverse positive 0.125. That is, cos is positive. Therefore, we will choose only angles in those quadrants in which cos is positive. Therefore, we'll choose angle in the first and the fourth and discard angles in second and third quadrant. Therefore, we'll say cos inverse of 0.125 is 82.8 degrees or 277.2 degrees. Therefore, x minus 30 is equal to 82.8 or 277.2. We send the 30 on the other side to obtain x equal to 112.8 degrees or 307.2 degrees. We'll take another example. This time we'll solve the equation root 3 tan x minus pi over 10 equal to 1. That is, we are looking for all those values of x, all those angle x between 0 and 2 pi, which satisfy this equation. Again, the first step would be to divide both sides by root 3, and then to take the inverse tan function, so that we obtain x minus pi over 10 equal to tan inverse 1 over root 3. If we do that using the calculator, we obtain 0.524, which is the principal value. But note that you must remember that tan of pi by 6 is 1 over root 3, so that the exact form exists here, and it is equal to pi over 6. The next step would be to find all the angles related to pi by 6. In the second quadrant, it will be pi minus pi by 6, which is 5 pi by 6. In the third quadrant, it will be pi plus pi by 6, which gives us 7 pi by 6. In the fourth quadrant, it is 2 pi minus pi by 6, which gives us 11 pi by 6. Again, here we are looking for tan inverse of positive 1 over root 3. So, tan is positive in first quadrant and third quadrant. So, we are going to take angles in these two quadrants and discard the angles in the remaining two quadrants. Therefore, we'll say tan inverse 1 over root 3 is equal to pi by 6 and 7 pi by 6. So that we can write x minus pi over 10 is equal to pi by 6 and 7 pi by 6. Sending the pi over 10 on the right hand side, we obtain x equal to 4 pi over 15, 19 pi over 15 radian. Now we are going to look at another type. You will note that we have tried to categorize the different trigonometric equations so that you can remember which strategy to use whenever you are asked to solve a trigonometric equation. So let's look at this trigonometric equation. 2 sine x minus 10 equal to minus 1. Minus 1. That is, we are looking for all the angles between 0 and 360 degrees which satisfy this equation. Again, the first step would be to divide by 2 and then take the inverse sine function, so that x minus 10 will be sine inverse of minus half. Now, if you perform sine inverse minus half on your calculator, you will get minus 30 degrees. But in order to use the relation chart, we want a positive angle and an angle in the first quadrant. So, you will use your calculator to find sine inverse plus half. Yes, sine inverse plus half. Although, we had to find sine inverse minus half. So, we find sine inverse plus half, and the answer is 30 degrees. And Next step would be to write down all the related angles to 30 degrees. We have already seen that they are 150, 210 and 330. Now, we want sine inverse of minus half. That is, we are looking for those quadrants in which sine is negative. And we know that they are the third and the fourth. So we are going to take angle in the third and the fourth. We are going to discard angle in the first and the second because sine is positive in first and second. Which means sine inverse of minus half is equal to 210 and 330. So we are going to write x minus 10 equal to sine inverse minus half. It is equal to 210 or 330. Sending the 10 on the other side, we obtain x equal to 220 and 340 degrees. So we are going to look at another type of equation, type 3. And here we'll look at multiple angles. Before we start, let me remind you that sine of ax is not equal to a sine x. For example, sine 2x is never equal to 2 sine x. So this is a mistake that you should never commit. Sine 2x is never equal to 2 sine x. The example that we are going to take is the following. We have to solve cos 2x plus 10 degrees plus 1 equal to 0. And we are looking for all those angles x between 0 and 360 degrees which satisfy this equation. So the first step is to make cos the subject of the equation by sending 1 on the other side and dividing by 2. So that we have cos 2x plus 10 equal to minus half. Again, cos 2x plus 10 is never equal to cos 2x plus cos 10. Okay, so 2x plus 10 remain together. Next step is to apply the inverse cos function so that we have 2x plus 10 equal to cos inverse minus half again. As we said earlier, that if you have minus 10, you will still use your calculator to find cos inverse of plus half, the positive value, which is 60 degrees. And then the next step would be to find the related angles. 60 degrees in first will be related to 180 minus 60, which is 120 in second quadrant. Will be related to 180 plus 60, 240 degrees. Will be related to 360 minus 60, 300 degrees in the fourth quadrant. Now, because we have 2x, we will find angles related not just in one turn, but in 2 turns. If you had 3x, then we should take angles related to each other in first turn, second turn, and third turn. Now, how do you find angles related to 60 in second turn? It's very simple. You just have to add 360 degrees to all the related angles you obtain in the first turn. So let's see. To find angles related to 60 in the second turn, we add 360 to 60. We obtain 420. We add 360 to 120. We get 480. We add 360 to 240. We get 600. We had 360 to 300, we get 660. Therefore, this is angles related to 60 in the first term. These are the angles related to 60 in the second term. And we have obtained them simply by adding 360 to all those obtained in the first term. If you had 3x, then you should continue and find related angles in the third term as well. So, Here we are looking for cos inverse minus half. Therefore, we are going to take angles which are in quadrants in which cos take negative value. So as you know that cos is positive in first and fourth. But since we are looking for cos inverse of minus half, we'll take angles in the second and third. Second and third. We are going to discard all the angles in first and fourth. Cos inverse of minus half is equal to, therefore, 120, 240, 480, and 600. Therefore, we'll write 2x plus 10 equal to cos inverse minus half. And it is equal to 120, 240, 480, and 600. We send the 10 on the other side and then divide by 2. We get x equal to 55, 115 degrees, 235 degrees, 295 degrees. Note that all the angles for x are in the range 0 to 60, even though we took angles in the second quadrant because of the 2. Right? So, if you have free x, remember, if you have free x, you should take angles in the third quadrant as well, in the third turn as well, sorry. And how do you obtain those angles? Just add 360 degrees to angles obtained in the second turn. We are going to take another example to show to you how to solve trigonometric equation involving multiple angles. So the equation we're going to consider is the following. Square root of 3 sine 2t minus 0.1 equal to 1. In fact, we are looking for all the angles t which have value between 0 and 2 pi and which satisfy this equation. So the first step would be to divide by root 3, both sides, and then apply the inverse sine function, so that 2t minus 0.1 is equal to sine inverse 1 over root 3. And using the calculator, with the calculator on radian mode, we'll obtain 0.615 radian. The next step would be to find all the angles related to 0.615 radian. In the second quadrant, it is pi minus 0.615, which gives us 2.53 radian. In the third quadrant, it is pi plus 0.615, which is 3.76 radian. In the fourth quadrant, it is 2 pi minus 0.615, which is 5.67 radian. And because we have double angle here, we will take related angles in the second turn. And they are not difficult to find. You just have to add 2 pi to each of them, each of the angles which we obtain in the first turn. So 2 pi plus 0.615 is 6.898. 2 pi plus 2.53 gives us 8.81. 2 pi plus 3.76 gives us 10.04. And 2 pi plus 5.67 gives us 11.95. And we are looking for sine inverse plus 1 over root 3. So we are looking for angles in those quadrants in which sine is positive. And you know that the quadrants are the first quadrant and the second quadrant. So we are going to take angle in the first and the second. First quadrant, second quadrant. And we are going to discard angles in the third and the fourth. Therefore, we'll say that sine inverse 1 over root 3 is 0.615, 2.53, 6.898, and 8.81 radian. We send the 0.1 on the other side and then divide by 2 to obtain angle T as 0.358, 1.32, 3.499, 4.46 radian. So again, Since we had double angle, we took all the related angles in first turn and second turn. If we had 3t, we would have taken related angles in the third turn as well. Let us look at the next type of equation. Here we'll assume that you are familiar with quadratic equation and the methods to solve quadratic equation, which you have studied in Form 5. So let's look at the example. 8 cos squared x plus 2 cos x minus 3 equal to 0. It's a quadratic equation in cos. So here, the first step in solving this equation would be to say, let y is equal to cos x. If we say y is equal to cos x, it means that cos squared x must be replaced by y squared, because cos squared x is cos x times cos x. So it will be y times y, it will become y squared. So we'll have 8y squared plus 2y minus 3 equal to 0. I repeat it. We started by saying let y is equal to cos x. So wherever there was cos x, we replace it by y. And cos squared x must be replaced by y squared. So we have 8y squared plus 2y minus 3 equal to 0. This is a quadratic equation, and you can use any method to solve the quadratic equation. Here we have used the factorization method. So we have factorized the quadratic equation and solved it to obtain y is equal to half or y is equal to minus 3/4. So y will be then replaced by cos x. So that this means cos x equal to half, and this one means cos x equal to minus 3/4. And we will solve each one of them. Note that we had a quadratic equation at the beginning, and this has resulted in two simple trigonometric equations, cos x equal to half and cos x equal to minus 3/4. We are going to solve each one. Cos x equal to half means x equal to cos inverse of half. So if you use calculator to find cos inverse half, you will get 60 degrees. And we find all the related angles. Now, since cos is positive, we'll take angles in the first and the fourth only. Therefore, we'll say x equal to 60 or 300 degrees. Cos x equal to minus 3 over 4. So, x equal to cos inverse of minus 3/4. Again, since we have minus 3/4, we'll use our calculator to find cos inverse of plus 3/4. And we obtain 41.4 degrees. And we find the angles related to 41.4 degrees in the remaining quadrants. In the second quadrant, 180 minus 41.4, 138.6. In the third quadrant, 180 plus 41 plus 41.4, 221.4 degrees. In the fourth quadrant, 360 minus 41.4 is equal to 318.6. But cos x is negative. Cos is negative. Or we are looking for cos inverse of minus 3/4. Therefore, we'll choose angles in the quadrants in which cos is negative. We know that cos is positive in first and second, so we'll discard them. Cos is negative in second and third, so we are going to take angles in the second and third quadrant. So x equal to 138.6, 221.4. Hence, the solution is x equal to 60, 300, 138.6, 221.4. So we have written the angles in ascending order. We are now going to look at the three main trigonometric identities. There are many trigonometric identities, in fact, that you will find, that you will meet in trigonometry. But these are the three main trigonometric identities which you can use without proof to prove other trigonometric identities or use them to solve trigonometric equation. Let's look at them. First one is sine squared A plus cos squared A equal to 1. The second one is 1 plus tan squared A equal to sec squared A. 1 plus cot squared A equal to cosec squared A. They have many applications in fact. I'm just going to show to you a few applications of the first one. For example, we can use the first one to replace sine squared by 1 minus cos squared. Or we can replace cos squared A by 1 minus sine squared. And it holds for any angle. That is, it is equally true to say that sine squared theta plus cos squared theta equal to 1. Or it is also true to say that sine squared 2x plus cos squared 2x equal to 1. We are going to now use the trigonometric identities to solve a trigonometric equation. The equation that we are going to solve is 4 cos squared theta plus sine theta minus 1 equal to 0. Note that in this equation we have both cos and sine, and we cannot solve this equation directly, because to solve an equation we must have all the terms containing sine only or cos only. So here we either have to replace the sine in terms of cos or the cos squared in terms of sine. As you know from the identity, it's easier to replace the cos squared by 1 minus sine squared. So let's replace it. We replace the cos squared by 1 minus sine squared. And simplifying the equation, we obtain 4 sine squared theta minus sine theta minus 3 equal to 0, which is a quadratic equation. So we'll solve it using the previous method by saying let y equal to sine theta. We replace y by sine theta, and consequently we'll have to replace sine squared by y squared, so that we obtain 4y squared minus y minus 3 equal to 0. Using method of factorization, we solve this equation to obtain y equal to minus 3/4 and y is equal to 1. Replacing y back by sine theta, we obtain sine theta is equal to minus 3/4 and sine theta equal to 1. We solve this equation to obtain theta equal to sine inverse minus 3/4. So we'll still find sine inverse of 3/4. We obtain 0.848 radian. We found the related angles in the second. Pi minus 0.848, it is 2.293, and we find angles in the third and the fourth quadrant. Now, since theta is equal to sine inverse of minus 3/4, we'll choose angles in the quadrant in which sine is negative. And we know that sine is positive in first and second, so we discard them. Sine is negative in third and fourth, so we're going to take angles in the third and the fourth quadrant. Sine theta equal to 1, theta is equal to sine inverse 1. We find using our calculator that theta is equal to pi by 2. And we find all the related angles in the fourth quadrant. Now, sine inverse 1, so we are looking for sine inverse of a positive number. Sine is positive, therefore we are going to take angle in the first and the second quadrant in which sine is positive. Hence, theta is pi by 2. We are going to write it once only. Theta equal to 3.989 radian or 5.35 radian. We are going to write theta as pi by 2, 3.99, 5.44 radian, giving our answer to 3 significant figures as required by the rubric in front of the questionnaire. So viewers, we have now reached the end of today's program. We have seen the 6 trigonometric functions, the sign chart, the relation chart, the main trigonometric identities, and their use in solving trigonometric equations. We have categorized the equation in order to help you remember the strategy used to solve them. Thank you for listening to us. Should you have any question or suggestion, we invite you to write the Mauritius College of the Air on the following address. You can give us a phone call on 403-8200, or you can also visit our website on the following address: World Wide Web, www.mcawebcast.org. We would like to thank the production team of the MCA and of course you viewers for your kind attention. Until next time, it's goodbye from us.